Okay, question 13. We've got an integration problem. We've got to use a substitution of x is equal to a sine squared theta to transform this integral into this one. Let's have a go. So there are three things we've got to do in this transformation. We've got to transform the x limits into theta limits. We've got to also transform the dx into a d theta, all from this substitution, x is equal to a sine squared theta. So let's get that preparation work out of the way. And we'll do the limits first. The old limits are from 0 to a. So if I make x is equal to 0, what will make this true? Well, a is a positive constant, so that's not going to help us. So sine squared theta must be equal to 0. And the first value of that to be true is that theta must equal 0 as well. Now the value of a, and if you cancel the a and take the square root, is that sine theta must equal 1, and therefore theta equals pi by 2. And that's confirmed in the question suggestion of where we should get to. Now the transformation of dx to d theta. To do that, we've got to differentiate this guy with respect to theta. The constant remains unchanged, and the differential of sine squared using the chain rule is 2 sine theta cos theta. So therefore I can say, pretending this to be a fraction, dx is equal to 2a sine theta cos theta d theta. Now the integral itself. There it is in x form, and now we do the substitution. So this becomes the square root of x is the square root of both of these terms. So this is root a sine theta. And there's the other substitution. And you can see I can take a root a factor out of this square root and multiply it by the other root a. So this becomes a sine theta and the square root of 1 minus sine squared theta. Now 1 minus sine squared theta by one of the Pythagorean identities is equal to cos squared theta, and the square root of cos squared theta is simply cos theta. So this becomes a sine theta cos theta, and that's the third of the preliminary results that we need. Let's put this all together. It's now the integral from 0 to pi by 2. The integral itself is a sine theta cos theta, and we multiply it by the new version of dx, which is 2a sine theta cos theta, and this is d theta. So I've pulled the a squared out the front and the 2, so we've got 2a squared sitting outside the integral from 0 to pi by 2 of sine squared theta multiplied by cos squared theta d theta. We're still not quite home, and you can see where we're heading towards. We're going to be using the double angle formula. And here it is. And you can see we haven't got sine theta cos theta, but we've got sine squared theta cos squared theta. So I need to square both sides and then divide by the now squared 2, which is 4. So this is equal to 2a squared. And for the moment I'll keep it inside. This is a quarter sine squared 2 theta. Pulling the 1 over 4 outside, I get a squared over 2, and the integral from 0 to pi by 2 of sine squared 2 theta d theta. And that's what they wanted us to prove. Okay, in part B, we've simply got to work the integral out. Our problem is the integration of sine squared 2 theta. And we've got to use another one of the versions of the double angle formula to work this out. And there is the cos double angle formula. And if I use the substitution of cos being 1 minus sine squared, I get this is equal to 1 minus 2 sine squared theta. So therefore sine squared theta is equal to a half 1 minus cos 2 theta. So with this we're able to transform the sine squared theta, yes, I know it's 2 theta, so this is going to be a 4 theta, into two terms which are going to be much more easy to integrate. So this integral transforms into a half 1 minus cos 4 theta. And bringing the half outside the integral again, I get a really quite simple integration of 1 minus cos 4 theta d theta. And again, this is from 0 to pi by 2. And I think I'm going to come up here to complete the question. The 1 integrates to theta, and this becomes sine 4 theta, but we've got to multiply it by a quarter. The limits again from 0 to pi by 2. We're now substituting values in. So this is a squared over 4 theta pi by 2 minus pi by 2 going into here means the sine of 2 pi, which is 0. Now the naught's going in, this is now another 0, and the naught going in here, again, the sine of naught is 0. And because this is negative, this will be plus 0. Doesn't really matter, of course. And this is equal to pi multiplied by a squared over 8. And that's equal to the result they've suggested if k is equal to an eighth. And that's the end of question 13.